Good afternoon. Bridge joint safety and concerns and site practices is what we planned on talking about today. I want to thank the partnership for allowing us to speak, and also like to give credit to the team that helped put this presentation together. It's really important to look at bridge safety from different points of view and try to see the different aspects of it as it progresses. When our team huddled together at the end of the fall to kind of start presenting and developing what we wanted to present today, safety seemed to be the large topic of the day. And in my mind, I went back to a documentary that I saw on National Geographic. And I know it seems very simple, but in this documentary, I think it explains exactly how far we've come in this subject of bridge safety. That project was actually the Golden Gate Bridge. As you can see, there's some facts there. It's a $35 million project. The construction phase was from 1933 to 1937, so 4 years of construction. And they pioneered the safety culture, and I think we use safety culture as a real loose term now to kind of describe what kind of safety we have today. But these guys were standing on the edge of that, and they were pioneering that. And you can see that through the fact that they had a mandatory PPE, the hard hats. You can see they leaned heavily on the mining industry for development of that. And they also had mandatory eye protection, something that we see common now today. That eye protection wasn't necessarily so much for the particulates coming into the eye as much as it was for knocking the glare down. I think they recognized that tripping hazards and falling was a large risk to them. So much so that they installed a safety net under the bridge, which cost them somewhere around $130,000, which was a monumental expense of the time. But the last point here, I think, is really what drives it home for me, because I'm kind of a numbers guy, so I like to move numbers around. And they declared a safety goal, and that's something that we do common now. At the beginning of every year, we decide, zero incident rate or no lost time accidents seems to be the par for the course, if you will. But these guys stated that they were willing to accept one fatality for every $1 million spent, which was, when you're willing to establish, life and death situations with how much money that you spend, really kind of drives it home. We can take, the math behind it. We can take the $1 million of the 1933, the buying power of $1 million, and project it to today, and it was roughly about a 15-to-1 ratio there. So that's like saying we're willing to accept one fatality for every $15 million that we spend today. That's a tough pill to swallow. When you look at some of the larger construction companies that may have $2 billion worth of construction in a year's time, could possibly be facing 130 deaths a year, which is astronomical. So how does bridge maintenance and preservation work hand in hand with bridge safety? You can see the relationship that we've put up there, and I think the key thing from this slide is that you just all 3 points seem to keep the long-term preservation of the structures as key ideas. The implementation of a bridge preservation program reduces the deterioration of existing structural elements and critical elements. The maintenance of the bridge expansion joint specifically keeps structures at a good state of repair. And finally, the execution of best practices enhance the overall performance of the project. So specifically when we're addressing bridge joint safety, we're going to cover 3 major projects in our discussion. One would be the safe use of the system type. We want to answer questions like, are we using the right system to address specific points of potential failure? Safe installation practices should answer questions like, have we staged the construction sequence properly, and now handling and placement potential weaknesses of the system. Safe use of bridge maintenance will obviously answer questions like, what does a good maintenance program look like, and the system approaches around that. And then finally, what you see overall is that we want to enhance the overall performance of our project. So what are some common hazards that we're viewed in the improper selection of a bridge joint system? Often we'll use the wrong system based on the movements, and during the expansion phase, we'll improperly size the material, focuses on forcing us to rely solely on the bonding agents, ultimately failing the system or ripping it. So what factors do we want to consider to be safe and successful? Obviously, joint orientation is critical due to the forces being applied to the joint either through a skew or through longitudinally. I think we can also agree that more so on the longitudinal joints, they pose more stringent limitations to potential risks to motorcycle traffic and bicycle traffic. Also, staging of construction around splices, which we can all agree sometimes is unavoidable. It's also something that we need to pay attention to, especially when it's done in the wheel path. I think a lot of times we fail to throw that 6-inch section of seal away when we probably should just go ahead and continue with the additional material just to make it to at least our staging area. Some other factors to consider are ADA compliance and addressing the use of snow plows. For ADA compliance, walkways and sidewalks utilized without cover plates present pedestrian tripping hazards. In some other colder climates, snow plows are often create header and seal damage. We can prevent that by using the snow plow plates used in the picture below, and also by just tilting the skew of the blade as it comes across the joint to prevent it from dropping down in. I want you to keep in mind that also that proper seal depth is critical for any of these factors to be successful. When utilizing the best installation practices, it's important to also identify the common activities associated with installing the expansion joint. And with the multitude of activities that you see here, and in combination will be performed in confined spaces and adjacent to traffic, fugitive dust, proper handling are common factors standing in the way of a safe construction sequence. You know, sometimes the cause of and effect of relationships between the hazard and injury is immediate. Sometimes we can recognize the fact that we trip or we fall or a cut to a hand forces us to recognize that maybe we need to get first aid or seek additional help. But that's not always the case with bridge joints. Commonly because the first stage of bridge joints is sawing or cutting or sandblasting. In addition to the physical hazards associated with the saw blast or blast spot, we also need to pay attention to the risk of silicosis. Silicosis is a long-term lung disease caused by inhaling silica dust that can come from abrasive blasting agents such as rocks, sand, and bagged mortars. Silicosis can lead to lung cancer, COPD, bronchitis, respiratory failure, and even death. The effects or feedbacks are delayed for years, so you may be able to get away with it today or tomorrow, but eventually there'll be consequences. OSHA has updated its policies regarding silicosis. For example, you may still need to wear that respirator even if you're using a wet saw or a vacuum or some sort of dust collection system, depending on the time of operation and shift. Updates can also be found on OSHA.gov. After the prep work is done, we still need to remain diligent and be aware of hazards associated with the chemicals that we're using to install our expansion joint systems. Product safety data sheets would always need to be reviewed prior to beginning any work. And in this slide here, we've reviewed a couple of the data sheets for some common chemicals that are used in many states, and thought it might be a good idea to cover them. One of them is the way that we mix the materials. Sometimes we're not paying attention in the manner of the way the chemicals are mixed, and they could cause a flash fire. Breathing high concentrations can also cause irregular heartbeats and can be fatal. A common cement-based material states that in small amounts splashed into the eye can cause irreversible tissue damage and even blindness. Other common warnings include respirator type, as well as chemical-resistant gloves, tightly fitting safety goggles, and face shields. Now think about the last time that you was on a job site, and did you see these precautions in place? Did you think about safety beyond turning on your strobe light, putting your hard hat on, or your vest when you entered the construction site? Safety is everybody's responsibility, from the owners to the consultants to the contractors and subs. And if you see something that isn't safe, you should take a minute to address it. Because the guy that's leaning over that mortar mixer, breathing that dust all day long, or the guy that's wiping the solvent on his arms to get the epoxy off, may not recognize the long-term effects that he's causing. This is also why it's important to have a toolbox meeting or a pre-shift meeting prior to beginning. A short crew-led meeting that addresses safety concerns directly associated with that shift's work is important time to save a coworker from performing an unsafe activity. It's also time to address the near miss that occurred on the previous shift. I want to pause here because I had a contractor mention to me one time that all of his safety policies were written in blood, and I thought that was alarming to me because that told me that he didn't use some sort of near miss program, and a near miss program would eliminate any of that sort of bloodshed to happen. Traffic safety is also additionally paramount during the pre-shift meeting. Proper staging of construction is also important. So how many times have we staged that traffic switch and the splicing of that expansion joint in the same area? Often we fail to utilize that shoulder, maybe shift traffic over 3-4 more feet that allow us to be able to work in that critical area of traffic switch. We can also use traffic spotters. Traffic spotters are very important to create a focal point for the traveling public to be able to view that individual working in that staged area that may be out of the view of traffic but still exposed to it. Another way we can reduce our exposure to traffic is through choice of materials. This can be successfully implemented by choosing armorless joint technologies that are quick and easy to install, and by using rapidly setting materials such as elastomeric concrete that usually set within an hour. And finally, proper handling and installation. Handling of the material safely through proper lifting techniques and utilizing chemical data sheets is paramount to individual safety of the crew members. Proper lighting is also paramount for the traveling public and the crew members. And we always need to remember to point those lights away from the traveling public. I've come in through many job sites where the light plants are pointed right in my face as I'm coming through, and I can't see the proper staging area. I can't see where the barrels shift over to shift traffic out of the way. So I think it's just as important that the traveling public sees the staging area and the entire construction area as it is for the crew members to see the work that they're immediately working on. So finally, in the safe use of bridge joint systems, remember what our objective is here is to enhance the overall performance of the project through this global idea of bridge joint safety. Some of the common hazards that we see are lack of preventative maintenance, allowing for excessive edge pressures and improper adhesion that lead to spalled headers and leaky joint systems. We can also promote public safety as an industry through reducing of our carbon footprint. By reducing the carbon footprint, we promote preservation above replacement. By reducing the need to produce additional cementous materials that are harmful to the environment. Some facts about the cement manufacturing is that it accounts for nearly 5% of the global emissions, which is with a staggering rate of 500 pounds of CO2 per cubic yard of concrete produced. When we begin to preserve our bridges, we speak directly to joint maintenance that prevents water from penetrating critical components while addressing dynamic loading at the header to prevent concrete spalling at the joint. So what kind of program do we need? A bridge maintenance program should proactively seek and address areas that need regular cleaning of the curb and along the joint opening and the seal, resealing and replacing joint systems that are leaking, and provide a more system approach that addresses the surrounding substrates. So where are we progressing from here? Today, DOTs are progressively advancing to improve safety and productivity by utilizing performance-based transportation planning processes to develop safety goals and performance measures. By utilizing systems and strategies that have proven effectiveness and utilizing advanced monitoring techniques such as drones to reduce our exposure to traffic and daily monitoring. So to place a capstone on the entire discussion today, if I had to replace integrity there with a word, it would be reliability. By choosing the right joint system for the right application, we can make sure that our systems are more reliable and systems that we can count on. And by installing reliable systems with the right tools and proper procedures, we're going to increase the long-term performance and make our joint systems last longer. And then finally, responsibly managing our bridge maintenance program through evaluating, constructing, maintaining bridge deck joints will keep our structures in a good state of repair for years to come.
About the use of elastomeric concrete to speed up impacts on traffic control. What experience do you have using elastomeric concretes in deeper blockouts, like for armored strip seal systems, especially where you've got a lot of hardware that you're consolidating around?
We use it with strip seals normally. You can layer it. You can layer and put it in layers, and it should bond to itself.
Okay. 'Cause I've heard issues with you get accelerated rutting from creep effects.
I'm not familiar with that one.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.